Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. I'm Saurabh, your instructor for this course. So from today, we'll be start learning core concept of data structure. In the previous videos, we have learned basics of Python. We have seen how to install Python in our system. Then we have run some code, some basic code. Then we have seen what is loops in Python and what are conditional statements in Python and many more, right? Now, from today's lecture, we'll be start learning core concept of data structure. So let's start. First, let's start with our first data structure that is called array. What are arrays? Arrays are basically used to store multiple items in a single variable. Now we have seen that to store single value we use variables, right? But for arrays, we used arrays to store multiple variables, multiple items in a single place. Now, when we talk about array, there are two things in Python. One is array modules, and another is list. So those are basically same, but there are some difference in there. So arrays in Python is basically Python arrays are dynamic in nature. Means their size is not fixed like when I say about Java or C++, those arrays are static. Means when we define the array, we have to define the size of it, right? If it is of size 10, then we can't change that. Means we can't add further element to this list or array. But in Python, this list are dynamic in size. Means if initially it only contain three element, then if we want to add more element to it, then we can add it. So this list and array modules both are dynamic in nature, but there are some difference between them. Array from this array modules is only contain a similar kind of data type. Like here, it is only storing integer data type 1, 2, 3, 4, and 5. But we can't store string to it. To create arrays that have string data type, we have to create another arrays, right? But in list, Python lists that are flexible. Like we can store number, integer, or float value, or string, boolean value to it, or an object to it. So this is very flexible. So that is basically difference between a list and arrays. In our whole lecture series, we'll be using this list. We'll be using this list. So let's go to our VS Code. Let's create a array. To create an array using list, we have to first name it. Let's say ARR. And now to create array, first you have to use this square braces, then put the elements. Let's say 10, 20, then 30, then 40, 50, 60, 70, 80, 90. Okay, now let's print this array. Print ARR. Okay, now let's try to run this code. Now you can see this is printing this array. Now let's talk about length of the array. What is length of an array? Length is nothing but how many elements are there in that array. So you can see currently there are 9 elements in that array, right? Now to print the length of the array, we have a special function called len function. And inside that len function, we have to put this array. Now let's try to run this. Now you can see the size of this array is 9. So this is called length of the array. Now, when I talk about array, so there are basically two things. The value that are stored inside an array. So this value is 10, 20, 30, right? 40, 60, 70. These are called elements. Elements in the array, right? The values are called elements. Now, each element are identified as a unique entity that is called index. An index always help us to get the reference of that element when we try to try to access the element or try to modify the element in that array, because there are 9 elements in that, right? Now how to uniquely identify each element? To do that, index help us. And in Python, index always start from 0. The first element, the index of the first element, will be 0, then index gradually increases by 1. Like the first element will be, the index of the first element will be 0, then the of the next will be 1, then next will be 2, like this. And up to what? Up to the length of the array minus 1. Because if we consider the length of the array is 9, then last index will be 8, right? So here the length of the array is 9. So what will be the last index of that array? It will be nothing but 9 minus 1 equals to 8. This 8 you can see here, right? So this is called positive indexing. This is start from initial element to the last element. Now there is another thing called negative indexing, and this negative indexing always start from the last index. When we try to access the element from the last of the array, then we use this negative indexing. And negative indexing always start from minus 1. So the last item will be minus 1. So the last negative indexing of this element will be minus 1, then the previous will be minus 2, minus 3, minus 4, like that. Okay, this is all about indexing, and indexing always help us to get the reference of that element. Now if we want to access this 30, what we gonna do? We'll be just writing array, then what is the index of this 30? Index will be 2. Now this will refer to this element. Okay, similarly if we would try to access this 80, what are you gonna write? Using negative indexing, we'll be writing array, then square braces, then what is the negative indexing of this? Minus 2, right? Then it will be access to this memory address, because the array is sequence of elements, right? Now to access each element we use this index. Now let's go to our VS Code and let's remove this. Now let's try to access the element at index 3. Let's try to print array of array of index 3. Now what will be the array of index 3? So this first element will be of index 0, right? This will be 0th index. So index of this will be 1, 2, 3, right? So at index 3, what will be the element? The value will be 40. Now let's try to run this. What is the output? Output is 40, right? Let's clear this out. Now let's try to find out uh, index of 5. Now what will be the value? 0, 1, 2, 3, 4, 5, right? 60, right? Now let's try to run this. You can see this is 60. Now in spite of this, if we just write 0, it will not return nothing but 10. Now if I try to run, let's say array of len of arr minus 1, means I want to access the last element. I want to access the last element. What will be the index of this last element? This is nothing but length of array minus 1, right? And length of array will be 9. 9 minus 1 will be 8. So it will be nothing but array of 8. Let's try to run this. So it is returning 90, right? Now let's take a look at negative indexing. So negative indexing, nothing but just remove this length of array and remove this space. Now if we just run this code, so it is returning 90. So minus 1 means we are just avoiding this length of array. Now if we try to print minus of 5, so what will be the output? This will be minus 1, this will be minus 2, minus 3, minus 4, minus 5, right? This will be returning 50. Now let's try to run this. You can see the output is 50. Now let's see how we can iterate over an array. Iterate over an array means we have to go through each element and in that array and we have to print it out. Means first we have to go to at index number 0. So first we have to print 10, then we have to print 20, then we have to print 30, then we have to print 40, 50, like that. Means what we have to print? We have to just print array of 0, then array of 1, array of 2, like that up to len of array minus 1, right? So that we have to print. Now how we can print that? You can see this indexing is increasing gradually, right? By one. First is 0, then it is 1, then it is 2, then 3, 4, 5, 6, 7, 8, right? It is gradually increasing. Now in the for loop lectures we have seen that if there is some sequence or if there is some range, so here you can see this is ranging from 0 to 8, so we can directly apply loop here, right, to avoid repetitive task. Now similar thing here we can apply. We to iterate over an array we have to write for, then let's index I, then we can create a range. And what will be the range? Range will be from 0 to the last element, right? Length of the array. So we can directly write len of array. So that will basically do the same thing that we have if we write, let's say 0 to len of array and increment by 1. So we can write like this, but in short we can just remove this. This will basically create a range from 0 to length minus 1 for array in range. And now let's try to print this. Print array of I. Now let's try to run this. You can see this is printing from 10 to 90, right? So this is basically index approach. Using index we can write this. Now there is another approach called iterative approach. Now in spite of this index we can directly access the elements using iterator. For to do that we have to write for yearly in then array. We don't use this index length, that range function will be directly using array, then print yearly, right? Now if we try to run this, let's clear this out. Now if we try to run this, now you can see this is also doing same. So this here the element represent each element 10, 20, 30, 40, right? And there are another thing that is called least comprehension. So this is basically shorthand notation. Like in spite of doing this, if we write let's print I and for I in error. So this is called least comprehension. Now if we run this, we can see this is also doing the same thing. So what is the difference? Difference here is it basically returns a whole new array. This least comprehension basically used to copy a array from an array. And this iterative approach basically used to iterate from starting element to last. But using this for loop, we can iterate from any index we want, from any, from let's say from 2 to let's say length minus 3. That we can do. We can choose from where to where we want to iterate. But for iterative approach we have to iterate from this to this, from starting to ending, and this basically returns an array. Now tell me what will be the time complexity for this approach and this approach, and what will be the space complexity of this approach and this approach. Let's try to understand. Now for this approach, this particular approach, what will happen? It will basically run first element, second element, third element, like that, right? So if the size of the array is n, then it will execute the code for nth time, because for 0th element it will execute, for 1 it will execute again, for 2, and up to length of the array, means n times. If n is let's say 10 to the power 8, size of the array is 10 to the power 8, right? Then it will be taking 10 to the power 8 units of time. That's why the time complexity of this iterative an array, it will be O of n. So iteration will take O of n time. Now this approach, iterative approach, will also take O of n time, because it also it also goes from each element, right? That's why the time complexity of this algorithm will be big of n, right? Okay, for this least comprehension, that will be also n, O of n, because it is running a for loop from each element, like it will be iterate over the element, right? So time complexity for this three approach will be big O of n, because if the size of the array is n, then it will run for n times. Now let's talk about space complexity. How much space is required to run this algorithm? Now to run this algorithm, how much space is required? There is nothing, right? For first iteration, we're just accessing the element using this index, then we're just printing it out. There is no space required, right? For this also, there is no space required, right? But for this list comprehension, it is basically returning us an completely new array from this array. That's why if the size of this array, if the size of this array is n, then it will also return an array of size n, right? It will return the same array. That's why the space complexity of this last algorithm will be O of n. The first algorithm, the space complexity of first two algorithm will be O of 1, O of 1. But for the last algorithm, it will be O of n, right? Okay. Now, let's talk about array slicing. So, what is slicing? Let's copy this. Let's okay. Now let's try to paste it. Okay. So let's say uh, I want to take some part of the array. I don't want the whole array. I want a part. Let's say from this to this, or let's say I want some part from this to this, and I want to create an array that only contains 30, then 40, 50, 60, and 70. Now I want to take some part of the array. How to do that? Now to do that, what we require, some initial position from where to where we want to take the slice. It may be from this to this, or it may be from this to this, like the only this element, or it may be from this to this, whatever it could be. First, we'll require initial position, and we require end position, right? From where to where we want to take the slice, and we want to give the step or jump, how much jump we want to perform, like it will be one jump or it will be two twice. Now let's see how we can create a slice from this. Let's say we want to create a slice from this to this, right? Now what to do? So what will be the initial position? Initial position will be 0. And what will be the ending position? Ending position will be 0, 1, 2, 2, right? Now to create a slice, let's take another array. Sliced arr equals to, first we have to write arr, then we have to write this square braces, then the starting position will be, initial position will be 0, then what is the end position? End position is 2, but this 2 will be excluded. That's why we want to write 3 here. And after that we have to write the jump, how much jump we want to perform. Let's say 1. So what will be the output? Output will be 10, 20, and 30. Means from 0 up to 2, that 3 will be excluded. Now let's try to print this. Print sliced error. Okay. Now let's try to run this. You can see this is printing 10, 20, 30. Remember, this ending index will be excluded. That's why we take 3. Now if we want to print from starting from 0 to end, what are you gonna write? Let's remove this. If we put nothing, it will automatically take 1 as step. Now to do last element, what are we gonna do? We're gonna write length of the array. And now let's try to run this. You can see this is creating an array 10, 20, 30, 40, 50 up to 90, right? Now we can apply negative indexing also. Okay, here length of the array means it will run up to length of array minus 1. That will be excluded. Now if we write negative indexing, let's say we're gonna start from minus 4, and will be until -2. Means what we will do, so it will be -1, it will be -2, -3, -4. Means from this to this, right? But this -2 will be excluded. Means we'll be printing from this to this, 60 and 70, -3 and -4. Let's try to clear this out and try to run this. Okay, and we have to, okay, we have put a space here. Now let's try to run this. Now you can see this is printing 60 and 70. So this is the initial or starting position, this is the ending position, and that will be excluded, like it will be run up to from -4 to -3. So that is basically slices in array, or we called in list, right? Now if we want to print a single element, then what we gonna write? Let's say from -4 to -3. Then what it will print? It will print -4, then it will go to -3, but -3 is excluded, so it will only print the element at -4. Let's try to run this. You can see this is printing single element, right? Now let's explore some list methods. So list methods are very important in Python. So these are basically inbuilt function that help us to manipulate with our list. So the first method is append method. What append does? Append add an element at the end of the list. Let's try to understand. Let's take this array, right? Now, what is the size of the array? So there are 1, 2, 3, 4, 9 elements, right? Now, if we just want to add another element to it, let's say 100. How we gonna do that? To do that, we have this append method. So append will do what? Append will add an element at the last. Okay, let's try to see how to do that. Let's take this array, right? Now if we just write array.append and we want to add some element, let's say 120 to it, and now let's try to print the array. Let's clear this out and let's try to print this. Okay, let's try to print this. Okay, now we can see this 120 is added at the last. Okay, so this is the first method. Tell me, what is the time complexity of this operation? So this array was already present, right? Now we are adding an element to it, but the array is basically same. The memory address of this array is same. We are just adding this element, and this array is extended up to this. Now the Python array is dynamic, so we can add any element. So for adding one element to this, it will take O of 1 times. Means because this is only one step process. That's why the time complexity of append method is big of 1. And space complexity, what will be the space complexity? Do we require any space? No, right? We're just adding this. So it will be also O of 1, right? So this is the append method. Now what is the next method? Next method is insert method. What insert does? Insert basically add an element at the specified position. So in append, element added at the last position, right? But insert can add at any position. Let's try to understand. Let's say arr dot insert. Okay, now the first thing will be the index where we want to add. Let's say I want to add an element, let's say 150 at index number 1. So what will happen? What will happen? So 150 will be added to this, and this will be shifted to right. Let's first, let's do that, then we'll be understanding. Let's insert 150, and now let's print this error. And if we try to run this, okay, the first will be the position of the array, then there will be element. Now if we try to run this, you can see At index number 1, so this is 0, see the output, this is 0, this is index number 1, right? At index number 1, this 150 is added. Then what will be the next values? Next values will be shifted by 1. Let's try to understand what is I mean by that. Let's remove this out. Okay, let's see. So these are elements, right? Now let's say we have a element 150. I want to add this 150 at this index number 1. At this index number 1. If I put this 150 directly to this element, then what will happen? This 20 will be removed, right? This will be replaced by, so this 20 will be removed and it will be replaced by 150. So this data will be lost, right? But we don't want to lost our value. So what we want to shift this by 1. What I mean, we want to shift this, then this, then all this element by 1. So we want to make a space here, then we'll be putting this 150 here. Then what will happen? Then all the elements will be shifted by 1, right? Now how to do that? How are we gonna do that? It will be not an easy process, right? Now to do that, so let's remove this. Now to do that, what will be the first step? First step will be, first will be creating an empty empty field here, right? A new element here, and that will be filled by none. Okay, now what is the next step? Will be make a copy of this element, make a copy of this element, then will be replace this by, will be replace this by this 90. Okay, so what are we gonna do? We're gonna copy the previous element is 90, right? Then we'll be copying the value from this 90, then we'll be adding to this. So now it is 90, right? Now just let's delete this. Okay, so what we do, we just copy the previous element and we put it here. Okay, now for this element, what are we gonna do? We're gonna take this 80, then we're gonna take a duplicate. Okay, now will be override by this. Now this 90 is deleted, now 80 has entered. Now at this element, what are we gonna do? We're gonna copy, make a copy of the previous element, and then we're gonna replace with this. Okay, now similar here at that element, what are you gonna do? We're gonna make a copy, right? 60, then we're gonna replace with this. Same for this also, we're gonna copy the previous element, then assign this with this. Okay, similar for this also, make a copy and replace here. Then for 30 also, copy, make a copy, remove 40, enter 30. Then at 30, just make a copy of this and remove this and enter by this. Okay, delete, delete. Okay, now what we're gonna do? We're gonna now finally take this 150 and we're gonna put here. Now just remove this 20. Okay, so this is the process. What we have to do first will be creating our space. At the end will be append a element, right? Then we gonna shift this element by 1. So what are we gonna do? We're gonna copy the first element, previous element, then store here. Then similarly from last till this, where we gonna insert, right? Then finally when we reach to that initial element, when we gonna insert that element, then we're gonna replace this by this 150. So that is the process here. So if we try to implement using for loop, then how it will be look like? Now this is an inbuilt method. Like now if we don't use inbuilt method and we want to write a code for this insert, then what we the code will be look like? So let's say we want to insert this 150, right? So first we're gonna make a function. Let's say def our custom insert. What will it take? It will first take the position, right? The position. Then what are we gonna take? Let's say value val, and let's take array error where we want to insert. Now what is the first thing? So we'll get the value. First will be append one element at the end, right? Previously we have seen we want to add none at the end. So first we're gonna put array dot append and append by none. Okay. Then what is the next step? We're gonna iterate a for loop. Let's run a for loop for I in range. The range will be start from the last index, right? So what I mean by that, let's try to understand first. Uh, okay, let's take the same array. Okay, so what is the first step? First step, we have just added an element here and added with none, right? Added with none. So that is the first step. That is the first step. We appended none here. Okay. Now, what the array size is up to this. The array is up to this. Okay. Now, what will we wanna run? We're gonna run a for loop from this last index. Okay. Then what we gonna do? We're gonna copy this previous element to this. Okay. Means if we at last index, then we gonna do array of current element, current index. Okay, equals to array of previous element I minus 1. That we gonna do for each and every element. And from where to where the for loop will run, let's say we gonna the last element will be this. Okay, so we gonna run from this to this. Okay, so this, let's say it is position, so it will goes up to this element, right? Means position minus 1. So it will start from lane of array minus 1 to position minus 1. So the first position will be lane of array minus 1, and the last will be position minus 1, right? But this minus 1 will be excluded. That's why we'll be writing position. Now the indexing will be decreased by 1. So these are higher value, right? These are lower value. So we're gonna decrease this element index by 1. Now what are we gonna do? We're gonna copy the previous element. Copy the previous element. Error of what is the previous element? Array minus 1. Then we'll be putting this value to array of I. Array of I. Right? Means whatever the previous value will be copy this value and will be assigned to this. What will happen? First, this last element, this 90 will be copied to this element. Then the for loop will execute again. Then this copy will be this into this. Then similarly this will be copied to this. So it will goes up to this. When it is at 30, what is gonna happen? This 20 will be copied to 30. Then it will also be 20 and this will also be 20. So this is the process. That's why the for loop. So for loop will start from length of array minus 1, means this last element, and it will goes up to position, this position, this position plus 1. Okay, here it will not be minus 1, it will be position plus 1. Okay, so it will goes up to this. Then we'll be copying this previous element to this element. And after that, what will gonna happen? So after that, this will be 20, right? This position index will be 20. Now this 150 will be adding to this position. So what we're gonna do, at array of that particular position, we're gonna insert this value. Okay, this is the operation. This is how this custom insert works. Now let's try to execute. Let's call this function first. Let's try to insert, let's say 200. And okay, first will be the position. So at, let's say, position 2, I want to insert 200. Now the value will be 200. The array will be array. Now if I run this and print this out, let's clear this out. And now let's try to execute. Now you can see at index number 2, that's 200 is inserted, and the right hand elements are shifted by ones. So that's how insert functionality works in Python. Now tell me, what is the time complexity for this algorithm? Let's try to understand. So to insert, we have to iterate over the whole array. Why? Because to insert at first position, we have to shift all the elements to the right, means we have to iterate over the array, right? Then when the for loop is over, then we'll be replace this value at that particular position. That's why the time complexity of this algorithm will be O of n. If the n is the size of the array, then it will be O of n. And what will be the space complexity? Are we taking any another array or something? No, right? That's why the space complexity will be big O of 1 for that insert operation. Now you can say that if I want to insert at last position, then what will be the time complexity? That will be big O of 1. But we consider worst case scenario. If we want to insert at the first position, then what will be the time complexity? That's why we consider worst case in big O of 1 notation. In the worst case scenario, what will be the time complexity? What will be the time taken by this algorithm? So I hope you have understood what is insert method. Now extend method. Extend are basically used to add to list. Let's say, let's remove this. Okay. Now let's say I want to insert another array. Let's say 45, 56. Let it. Now I want to add this array inside this at the last. What are you gonna do? For that we have this extend method. So extend method, what it does, it actually let's say array dot extend. Then so the name suggests it actually basically extend the array. Now if we just print this out, print error. Now if we try to run this, now you can see these array elements are added in the previous list. Okay, this 55, 45, 85. Okay, so this array, basically the memory address of this array and this array are basically same, that are not different, that are not creating a different array, that is basically operate on this. So it actually, what it does behind the scene, it actually takes the element one by one and append at the end. So that it actually does. Now tell me, what is the time complexity for this algorithm? Let's say the size of this array is n, and also size of this array also n. Then you have to perform n append operation, right, to add this. That's why the time complexity will be O of n. And what will be the space complexity? Space complexity will also be n, because we want to create an array, right? To extend, we want to create an array. Then we want to append that. For that extend method, the time complexity will also be, the space complexity will also be big O of n. Now what is the next method? Next method is pop method. So normally pop, what it does, it actually remove element at the last. Let's say if we want to remove element, the last element, let's say 90, then what are you gonna do? We're gonna write this pop array dot pop, and now if we print this out, print array, let's clear this out, and now let's try to run this. Now you can see the last element is removed. This 90 has removed, and the remaining element will be up to 80. Now this method is basically used to remove last element. Now we can use this pop method to remove at a particular index. Let's say I want to remove element at index number 1. Then we have to put the index here. Then pop will be remove the element at index number 1. You can see, so 10, after 10 it is 30, means 20 has removed at index number 1. Whatever the element is, it is popped. Similarly, what will be the time complexity for this algorithm? So what it will does, it will basically left shift the elements, means this will be copied to this, then this 40 will be copied to this, then 50 will be copied to this. So all the elements will be shifted to the left. So similarly, what we have uh, seen in the insert method, it is basically opposite to that, but the time complexity and space complexity will be same for this method. So it will basically, time complexity will be O of n, because it will iterate over the loop, and it will basically start from position to the last element for this. So you can try it by your own, so how this pop method does, and let's write in the comment what will be the output. And the last method is remove method. The remove method basically remove a particular element. So until now we have seen that if we want to remove element, we have to put the index of it, right? Now if I don't have the index, if I want to remove a particular element from this array, so for to do that, we have this remove method. So what remove method actually does, first let's try to write this. Remove, let's say 50. Okay, now when we write this 50, what it will do, it will search, first it will search for 50, and this searching will be linear search. It will be starting from 0th index up to this length minus 1, and once it find that element, it will not execute the further. So first operation will be, so let's say it will be remove 50. So first it will iterate, first it will go to 0th index, and it will check if this element is 50 or not. If this is 50, then it will remove that element. Then it will go to this element 20, then it will check again if it is 50 or not, then up to this. When it will goes to this element, then it will check that yes, this is 50. Then what it will does, it will basically remove this 50, and it will left shift the elements. So what will be the time complexity for this? The time complexity, first it have to search the element, it have to search the element linearly from left to right. To do that, we have O of n operation, because we are iterating over the array. What is the possibility? Possibility will be that the last element will be the that element. That is the possibility. For that, the time complexity will be big O of n. Then for left shift the element, that will also be O of n, means O of n plus O of n. That is basically nothing but O of n, because we remove the constant. So this remove operation will take O of n time complexity. Now let's see the output. What will be the result? Now you can see this is 10, 20, 30, 40. Then 50 is removed. Then this 60 is shifted to left. Then 70 is shifted to left. 80, 90. So if initial length of the array is 9, then after remove, the length of the array will be decreased by 1. Means it will be 8. Right? So these are all array methods. So that is very important, very, very important while we will be solving DSA problems. So I hope now you have understood what is array, basic concept of array, what is indexing, and how to iterate over an array, and how to change the element value, how to manipulate with an array, right? So, and at last we have seen what are list methods in Python. So that's it for today. See you in the next lecture. Thank you.